Hi, good evening. Tonight I'm going to show you how I choose my DC power source. DC power source is very important for the ham radio because most ham radio are running at DC power at 13.8 volts, which is battery power voltage. In my case, I have two radios. In order to buy a proper DC power source, I need to first calculate what's my maximum power need. This radio draws 21 amps at max, and this one draws 10 amps max. So total, I need 31 amps max at 13.8. So I bought this power source. This is the Astron 35MS, and it has the maximum output, stable output at 35 amps. So it's bigger than 31 amps. That is needed. This has adjustable knobs, so I can limit the amps to 0 to 40 amps, and the voltage can be adjusted from 0 to 15 watts. Another famous model is Astron 35RS. The 35RS, the difference is that they don't have the knobs. The voltage is fixed at 13.8, and they do have the meter, but no, that model does not have the adjustable capability. This one is very expensive. This one cost me $300 and very heavy, 25 pounds. Why it's so heavy and so costly? Because this is the linear power source. If I buy a switch power source, it's far cheaper and smaller. All our battery power, battery, all the cell phone power charger, they're the switch type. So it's cheaper and smaller. So now the question is that what's the difference between switch and the linear? Let's take a look. Here I have the several switch charger, and they output like 5-6 watts, very small, $5, and I hooked to this one. This is the probe, so this is one positive, one negative, and then I use the spectrum analyzer, not spectrum analyzer, the scope to take a look. Let's see. Okay, it's already running. It's already powered on, and let's see. Okay. Did you see that? What happened? Let me zoom in. It's not pure watts. It's not. It's about 9 watts here, 10 watts, but it's not smooth. It's choppy. So all those bumps here will introduce RF interference into your radio. So your radio need to be very sensitive, and the sensitivity of the radio will pick those signals and will interpret them as a noise. So this is not good. Let's look at the Astron performance. Okay, I hook up the, I'm sorry for the messy, I hook up the probe to the positive and negative of this Astron 35MS linear power source. And this is the, what do we see from the scope? Let me, you can see still some bumps here and there. As it's not as bad as the switch one, but it's still bad. So you can see that the linear power power source improves, but still not ideal. Okay, let's go to battery power source. Take a look. Okay, this is my battery, and it's hooked to the probe. Let's see the power waveform. It's running, so it shows that it's 12.7 watts right now. Let's see. Okay, let's see. Still noisy. I don't know why. Ideally, this battery power source should be flat. Anyway, I show you 3 power source. So the conclusion is not very obvious, but I know that linear power source is the best. The battery is the best. The linear, then is the linear power source. Then is the switch. Good night.